part of this unit is it's gonna relate to the Pythagorean identities in that like we have formulas that we can use for these. Again, for this unit, I'm not gonna make you memorize these. Like on your quiz on Friday, like this same text box will be on your quiz for when you need it. So you don't need to memorize them. And when we did the Pythagorean identities, I showed you like how they're derived. I'm not going to show you that with the double angle yet. Just trust me that they work and that there's a method behind them. When we do our next unit, I will show you where those come from in our next unit. So basically when you see something like this looks really simple to solve, like, oh, add the 1, divide by 2. However, we've never encountered something with 2 theta inside the parentheses, and that's kind of a problem. So anytime you see like a 2 theta, whether it's with sine, cosine, or tangent, you should automatically go to these formulas. So when you see cosine 2 theta, even though there's a 2 in front of it, that's fine. We'll put parentheses there, and we can just distribute into 2. We have to go over to our double angle identities and say, okay, well, cosine of 2 theta equals this cosine squared sine squared. So just like we were doing last week with the Pythagorean identities, if you see something that's equivalent or equal, you can just substitute it back in. So this is going to go in for where cosine of 2 theta was. No, these ones you will. I'll never have you have to memorize these, but the Pythagorean ones you will have to memorize eventually. What on the ACT?
Yeah.
The practice test that I did, they didn't come up, but like sine, cosine, tangent, like those ratios, like SOHCAHTOA, like that comes up quite a bit. But you usually don't see stuff this high level on the ACT. A lot of geometry and algebra 1, algebra 2 stuff. Yeah, I think when I look at the ACT, I think I view it as going through algebra 2. Yeah. Alright, so when that 2's out in front, I can distribute it in. Alright, so 2 cosine squared theta minus minus 2 sine squared minus 1 is equal to 0. Yes. Not instead of, in addition to.
So you're using like one to the other side and two to the other side
I don't know. Watch the next step, and then maybe it'll answer your question. All right, so it may I told you that this was going to help, and right now it kind of looks like it made more of a mess. When you're here, like in order to factor something, either all of the terms have to have something in common, like oh, you can take out a cosine from all of them, or they at least have to all be the same kind, like all sines or all cosines, whether the sines or the powers are the same or not. And that's not the case right now. Right, so what we're going to have to do is go back to the main Pythagorean identity, the sine squared plus cosine squared equals 1. Yeah. So, like, when I told you last week, like, you seriously need to do all of the practice that I give you for this unit, I was not kidding, because some of this stuff kind of sneaks in to other problems, and unless you try a lot of these on your own, you're not going to feel comfortable knowing kind of when to use one and not the other, or whatever the case may be. So, what's nice about this one, though, is that we have two choices. We can either replace the cosine squared, or we can replace the sine squared. In this case, like, it literally does not matter which one you replace, because we'll be able to solve it either way. So it's kind of personal preference. I don't think one way is easier than the other, so you tell me, what do you want to replace? Okay. Okay. Sine. Who wants sine?
Wait, I don't even know how to do it before. I figured it out.
It doesn't matter. It doesn't. That's why you, like, we're like, cosine, sine, cosine, no.
The one where
Cosine.
first.
Let's go cosine. I heard more cosines first. So, alright. So, if we're going to replace cosine squared, that means that we have to get that by itself over here. So, what do you have to do to both sides? Subtract the sine squared. So, cosine squared is equal to 1 minus sine squared. I know I didn't give you enough space to write about this. I didn't. So 1 minus sine squared is what we can plug in here. Again, we have another situation where we have a 2 in front. So it's going to be 2 times all this business. 1 minus sine squared. Then we have minus 2 sine squared theta minus 1 equals 0. It is kind of, it does look like it's getting worse before it gets better, but, alright, so what do we do with the 2 now? Distribute. So we have 2 minus 2 sine squared, and then the rest of it. Minus 2 sine squared minus 1 is equal to 0. Yes. Yes. Yeah, that's what you should do next. So next, like, clean it up. So you want to combine like terms. So these two can go together to make a negative 4 sine squared theta. And then you have your little bookends with like the 2 and the minus 1. Those two can go together to make it just plus 1. It looks a lot better now. If it's just a sign and it's, you know, we can easily get it by itself. Are we going to have to factor this? No, this is one of those simple equations now. So now, if you want to get sine by itself, what should you do next? Yep, subtract 1. And then divide by negative 4. Yep. So the positive 1/4. And then square root. Yep. So when you square root a fraction, remember that means you're going to square root the top and the bottom. So sine's going to equal just a half?
Or plus or minus.
Yeah, plus or minus. Anytime you were the one that introduces the square root into the problem, you gotta put the plus or minus. Okay, so how many different angles is sine going to be plus or minus a half? 4 of them. All of the over 6's. So pi over 6. No. No, because
There are 4s.
there's. Alright. So here's the thing, if the directions just said solve it between 0 and 2 pi, we'd be done. Alright, but I'm going to keep putting on here the solve for a general formula, because I think most of you, if you can at least get this far, I think a lot of you feel confident to leave your answer like that. But like, there's still some of you that are like iffy on like the plus pi k and the plus 2 pi k, so I'm going to keep making you do it until you feel good about it. I know you don't have enough space, it's fine.
There's enough space.
Yeah, I warned you to write small. Can't you just click extend page like I can? Alright, so when you look at this, pi over 6 is here. 5 pi over 6 is back in the second quadrant. 7 pi over 6, 11 pi over 6. You don't... Yes. So these two would go together, so you'd say pi over 6 plus pi k, and that accounts for the 7 pi over 6. And then your other pair would be 5 pi over 6 plus pi k. Woo! Woo! Yeah. Okay, your quiz on Friday is 5 questions. Yeah, not 5 of these, but like a lot of what I mean. It's a big quiz, but it's only 5 questions. You'll probably have like 1 like this. Yep. Number 2. This one's easier. I promise. This one's easier. So this one, when you take a look at it, this we have to replace. Like we have no choices there. Alright, so sine of 2 theta is equal to all of this. 2 sine theta cosine theta. So let's replace it. So this, to sine of 2 theta, is equivalent to sine theta cosine theta because of the formula. Okay, hold on. Before we finish this one, though, let me ask you this. If I had 2xy is equal to y, and I said set that equal to 0, what would you do? Not divide. Subtract y. Okay, so say you do divide by y. What's y divided by y? 1. Try to set it equal to 0. So don't ever divide something out. You're going to lose solutions if you divide it out. Just cancel it like that. So over here we have 2xy minus y. Are those y's going to cancel each other out? No. Yeah. Okay. So those are not going to cancel each other out. So if we go over here, we look at this. My first step to set this equal to 0 is subtract cosine from both sides. Okay. These cosines do not cancel each other out. Yeah. So we have 2 sine theta cosine theta, and then it's minus cosine theta equals 0. These, the 2 sine and the cosine, are a package deal. It's 2 times cosine times sine, or vice versa.
Cosines not cancel out then?
They do not cancel out. No. It's kind of like over here, I used it like 2xy's, like this. Like, if you subtract the y, you're usually not tempted to subtract the y. So, like, yeah. So, like, as you go through this trig stuff, if you are not sure if you're allowed to do something, if you're not sure if you're allowed to do something, replace them with x's and y's and ask yourself if you do the same with x's and y's. The rules will be the same. Okay, but like even if you're like, yeah, these cosines cancel, but in your mind you're going, but do they really? Like, replace it with x's and y's and ask yourself if you do the same thing. Succession. Now when you look at this, what do they both have in common? Cosine, so you can factor that out. So if I take out a cosine from both of those terms, the first one's just left with 2 sine theta. Do I need to put anything for the second part of it? Minus 1. Yeah. As you guys said that so quickly, because a lot of people, just be careful. Okay, so now, 7 equal to 0. So cosine of theta is equal to 0. 2 sine theta minus 1 is equal to 0. You solve from there. So for this first one, at what angles does cosine equal 0? So we're pi over 2 and 3 pi over 2. Are those 2 angles going to make the same line? Yes. So you keep the smaller one plus pi k. For this one, add the 1, divide by 2. So trying to figure out where does sine equal a half. What? Over 6 is all of them? 5 pi over 6. Are those two going to make the same line? No. So they both get 2 pi k. All right. So for this last one, not too bad. So we have to start by replacing this one. And what? Goodness. All right. So tangent of 2 theta is going to get replaced with 2 tan theta over 1 minus tangent squared. We still have this tan is equal to 0. All right. So good news, bad news. Good news, they're all tangents. Bad news is there's a fraction. So, how can you clear the fraction? So, all right, so if you want to clear a fraction, what do you multiply by? By the bottom, by just the bottom. So we're gonna multiply everything by 1 minus tangent squared theta, which seems like a lot, but here's the thing: when you multiply this by the fraction, they're gonna cancel each other out. So in this first term, all we're left with is 2 tan theta, and that was the goal: is to clear that fraction.
Plus.
Yeah. So we're going to have to do tangent times this. So I'm gonna write it out for now without distributing it, but I will here in a second.
That really does not influence.
It's not bad, don't worry. Good news is, on the other side, when you do 0 times 1 minus tangent squared, what are you going to get? Just 0. So really the only thing that causes you any strife is this in the middle. So distribute it. Yeah. So, and you can do that. You don't need to show that first step if you don't want. I mean, you can do it all at the same time if you want. But what we're going to end up with is 2 tan theta plus tangent theta. Now tangent times tangent squared. Think of it, what's x times x squared? To the third. Yep. So tangent cubed of theta is equal to 0.
Equals 0.
Equals 0. We haven't done anything with tangent cubed, but that's fine. No big deal.
Yeah, 3 tangent theta.
Yeah, so here's where you want to combine like terms. So these two go together. 2 tangents plus another tangent make 3 tangent. It doesn't even. So what do they both have in common? Tan. Now, before we factor this, you can. If I had 3x minus x cubed, how would you factor that? Tan x
minus x squared.
That's going to be the same. Okay, today when we did this, some people thought if you take out a tangent that you'd be left with 2 tan theta for the first one. Tan theta is a package deal. Yeah, together. So take out a tangent theta. So it'd be, this would go away. So it'd be 3 minus tangent squared. Yeah. Okay. And then you can solve it from there. All right, so I'm going to give you a minute to try getting both of those solutions from here. All right, so let's take a look at this. For the first part, I don't think you're having issues with the first part. If you take tangent theta and set it equal to 0, at what angles does tangent equal 0?
0 and pi.
0 and pi. Are those two going to make the same line?
Yeah.
Yeah. So we can say theta is equal to 0 plus pi k, or you could just say pi k. I like to keep the notation the same all the way, so I'm just going to leave it like that. So we're done with that one. This one, 3 minus tangent squared is equal to 0. What do you have to do first? Subtract the 3. Or you could have add tangent squared to both sides. That works if you're thinking about doing that. We'll get a negative... Oh, nope, that's a squared. Tangent squared theta is equal to negative 3. Can you square root it as it's written? No. Divide by negative 1. And then what's your last step to solve that? Square root it. So since we square rooted it, it's plus or minus the square root of 3. So how many angles does that happen at? All 4 of the over 3's. So it'd be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Yep. So if you look, this is quadrant 1 and quadrant 3. So these two together will make a straight line. So you would say pi over 3 plus pi k. So we're done with those. And then these two, yep. There are your solutions.